Hey there, welcome back to the channel. Today we're diving into the building blocks of the universe, atoms. Have you ever wondered what everything around you is made of? From the air you breathe to the screen you're watching this on, it all comes down to these tiny invisible particles. But what exactly are atoms? How do they work and why are they so important? In this video, we'll break it all down into bite-sized, easy to understand chunks. So all matter is made of atoms. However, atoms themselves are made of smaller subatomic particles called protons, neutrons, and electrons. Each of these subatomic particles have certain properties, and the specific number and arrangement of these subatomic particles gives an atom its mass number, atomic number, and electronic structure. Before we go into a bit more detail, let's just put the size of atoms into perspective. So atoms are very small. The diameter of an atom is 0.1 nanometers, which is 1 times 10 to the power of 10 to the power of minus 10. And to put this into perspective, 1 grain of sand has 10 to the power of 19 atoms. So you can imagine how small atoms really are. And a 70-kilogram human has approximately 7 times 10 to the power of 27 atoms. So the basic structure of any atom consists of a tiny dense central nucleus, which is approximately 1 out of 10,000th the size of an atom, surrounded by electron shells, which are sometimes called energy levels. The nucleus contains an atom's protons and neutrons, while an atom's electrons orbit the nucleus in the electron shells. So if we magnify this diagram makes it a little bit easier to understand, and this table summarizes it. So these three subatomic particles have a different relative charge and relative mass. It's quite important to remember this table because you sometimes get easy 2-mark exam questions which just require you to fill in the blanks. So the relative charge of a proton is 1. So it's easy to remember as it starts with P, so it's positive 1. The relative charge of a neutron is 0. So if you just remember neutral sounds like neutron, then the relative charge will be 0. So it'll be easy to remember. And the relative charge of an electron is negative 1. The relative mass of a proton and neutron is 1, whereas the relative mass of an electron is negligible, so it's essentially 0. So this periodic table shows all of the elements. Each element has a mass number, atomic number, and element symbol. So each one of these will have different numbers of protons, neutrons, and electrons. In any individual atom, the number of protons is equal to the number of electrons. So atoms have no overall electrical charge. Positive charges are cancelled out by the equal number of negative charges. Okay? So the sum of the number of protons and the number of neutrons gives the mass number. And the number of protons in an atom is called the proton number or the atomic number. And we represent the proton number and mass number of an atom numerically. So for example, sodium, which is represented by the elemental symbol Na, has 11 protons and 12 neutrons. Because a proton number is 11, we also know that sodium will have 11 electrons, as a proton number equals the electron number. So we can therefore calculate the number of protons, neutrons, and electrons in any atom if we know the proton number and the mass number. Okay? So electrons orbit the nucleus in electron shells, and these electron shells have fixed distances from the nucleus. Electron shells that are closer to the nucleus house lower energy electrons and are difficult to remove from the shell because the nucleus has so much energy. Now, different atoms have different number of electrons, and they'll have different numbers of electron shells. So the arrangement of an atom's electrons in its electron shell can be understood using 2 rules. So the first rule is that the first electron shell can hold a maximum of 2 electrons, and every subsequent electron shell can hold a maximum of 8 electrons. The other thing that you need to remember is that each electron shell must be filled before a new shell can begin to fill up. Okay? So following these rules, we can draw the electronic structure of an atom. So for example, for sodium, which has 11 electrons, we can draw the electronic structure. So the first shell will have 2 electrons, the second shell will have 8 electrons, and the third shell will have 1 electron. So 8 plus 2 plus 1 will give you 11, so that's a total of 11 electrons. And the other way that you can represent electronic structure is by writing it out. So you write it out starting from the shell closest to the nucleus. So in this case, you have 2, 8, and then 1. And each number is separated by a comma like this. Okay? So this will tell us that in the first shell there's 2 electrons, in the second shell there's 8 electrons, and in the third outer shell there's 1 electron. Now, atoms with incomplete outer shells are unstable, and they can react in chemical reactions with other atoms to gain a complete outer electron shell to become stable. And this is the basis of all of chemistry. So in this case, for example, as sodium only has 1 electron in the outer shell, it's unstable, so it's more stable in its Na+ form, which means an electron has been removed from the outer shell. So now the electronic structure is 2 and then 8. Now this can be a bit confusing because if an electron is removed, after the elemental symbol you have a plus, whereas if it's added on to make the shell more stable, it will be negative. So just remember that if an electron is removed, it's plus, and if it's added on, it's negative. So for example, with chlorine has 7 electrons in its outer shell, and it would require less energy to add on an electron, making it a full outer shell, than removing 7. So removing 7 electrons will require a lot of energy. So chlorine as an atom will gain an electron when reacting in a chemical reaction to form a stable 8-electron outer shell. Okay? So let's try a few exam questions. Again, you can pause the video here and have a go, and then we can go over them together. So the first question is, what 2 particles make up the tiny central nucleus of an atom? And the second question is, atom W has 12 protons and 14 neutrons. Give the mass number of atom W. Okay, so let's go over the first question. So which 2 particles make up the tiny central nucleus of an atom? So this is protons and neutrons. Protons are positive and neutrons are neutral, so it has a charge of 0. And the second question, atom W has 12 protons and 14 neutrons. Give the mass number of atom W. So in this case, the atomic number or proton number is 12. And to work out the mass number, all you have to do is add up the number of protons and neutrons. So 12 plus 14 is 26. And that's it. So keep watching, and I'll make a new video on chemical reactions and compounds. So just a bit more harder than this, but the basics of atoms will start making sense. So I hope you enjoy this video, and if you have any questions, then drop a comment below or send me a message and I'll be happy to help. If you enjoyed, like the video and click on subscribe so you don't miss any upcoming videos. Thank you for watching.